fifth graders! Welcome back to week 5 of remote learning. Wow, it's been such a journey and I hope you are learning so much and that you are having so much fun at home. I just wanted to pop on here really quick and just say that I am so proud of your perseverance and I'm so proud of everything that you're doing. Learning through remote learning has not been easy and I completely understand that. So I'm just very proud of you. Keep it up. We're almost done. We're almost done with 5th grade and you're going to be a middle schooler soon. So I'm very proud of you, and today's lesson we are working with brownies. Who likes brownies? Brownies are good. So we're going to keep working with fractions and decimals and doing all of that. So let's get to it. Alright guys, let's get started. This is Unit 7, Lesson 2.1, and we're on Week 5, Lesson 1 of Remote Learning. So the first thing that I want to talk about is reviewing place value, okay? Right here we have a number, 12 and 509 thousandths, and it's asking us to put it in expanded form. And we had an activity last week that had us do this, and I feel like a lot of people had some struggle with this, and we've learned this, so let's review it again, okay? When we're writing it in expanded form, we're thinking of powers of 10 and we're thinking about place value. Okay, so let's start with this 1. This 1 is in what place value? Well, our 1 is in the 10ths place value. Okay, so we are going to do 1 times 10, right? Because 1 times 10 gives us 10, right? Which is in our place value right here. Then we go to our 2. What place value is our 2 in? Our 2 is in the 1's place. So I'm going to do plus 2 times 1, right? Because if I do 2 times 1, that gives me 2. And I know it has to be 2 because it's in my 1's place value. Then I add another plus sign again, and I go to this place value. Okay, if we see right here, there's a decimal. So behind the decimal, we start to look at our place value, and this place value is the tenths. So I'm going to do 5 times, and I have to do it by powers of 10, but I have to remember everything behind the decimal is only a part of a whole, right? We don't have a whole number, so I can't do it times 10 because the place value that we have in 1 times 10 is very different from the place value that we have in this 5 right here, in this 5/10. So I would be multiplying by 1/10, right? That one part of the 10 that we're seeing. Then we add that again, and we move to our next place value, which is tenths, hundredths. So then we do our 0. It is a 0, so I can skip it, or I could do 0 times 1/100th, okay? And then I can add in the next place value, which is that 9. That 9 is in the thousandths, so I do 9 times 1,000th. Okay, and this is how it would be written in expanded form. Okay, when I do it back, I just look at the place value and I say 1 times 10 is 10, right? That gives us the 10 place value, plus 2 times 1 is 2. Plus, now I have to take in consideration my decimal, 5/10, plus the 0 hundredths, plus 9 thousandths. So this would be 12 and 509 thousandths, okay? Make sure we're reviewing stuff like this, especially with summer coming up so closely. We don't want to forget what we already learned in class. All right, now let's start talking about this brownie problem, okay? So our problems today are going to be focused on brownies. I love brownies, so let's get into it. We've been working hard thinking about multiplying and dividing with fractions. In this investigation, we're going to think more about operations with fractions and the relationship between fractions, division and decimals. So we're going to solve a problem today about sharing brownies. you might remember some problems like these from 3rd grade or 4th grade, but here's a problem. Five friends equally shared 6 brownies. How much of a brownie did each friend get? So before we start to solve this problem, what expression would we write to represent this problem? Okay, I have 2 different numbers that I can look at. I have this five friends, and they shared 6 brownies. Okay, so what do I have? What do I have to share? Okay, I have those 6 brownies to share, right? So I'm going to write 6 divided, because when I'm sharing, I'm dividing it, I'm putting it into parts, right? Putting my whole into parts. And how many parts am I putting it into? Well, I have 5 friends, and I'm sharing them with those 5 friends. So 6 divided by 5 equals blank. All right, so we're going to solve this problem. And how can I solve this problem? Well, I'm going to start by drawing out my brownies. I have 6 brownies, and I'm actually going to draw them kind of on top of each other like this in a row. Okay, and I'm going to do 6 brownies. So I have 1, 2, 3, 4, 5, 6 brownies, and I have 5 friends. And I want to share that with 5 friends equally. Well, something that I have great here, instead of breaking up these numbers, I know that every person can get 1 whole piece of brownie, right? 1, 2, 3. Oh. Let me fix that. I don't know what happened there. 3. Don't want to let me fill it. Okay, 3, 4, 5. And I made each color represent a different friend, right? So this friend is going to get 1 brownie. This friend's going to get another brownie. This friend's going to get 1 brownie, 1 and 1. So right now everyone has 1 brownie. But wait, there's this last brownie left. How can I break up this brownie evenly to share with my 5 friends? Well, I have to break up that brownie into 5s, right? So now I have 5 pieces, and now each friend is going to get that piece of the brownie. Okay, so each friend, if we see the color-coded picture, this friend that's in red, they get 1 brownie here, and then they get 1/5. So every friend gets 1 and 1/5. I want us to see right here, these equations, 6 divided by 5 equals 6/5, and 6 divided by 5 equals 1/5. We're going to solve more problems like these, and for each one, I want us to draw a representation and write the equation. Okay, so let's think about this. This is the same problem. Are these answers the same? Is 6/5 the same as 1 and 1/5? Well, yes, they are. They're the same. Just this one is an improper fraction. Remember those words that we learned. This is an improper fraction. And the one below is a mixed number. And I already showed you this one right here, this bottom one. So let's make this one. Let's represent this guy. So I'm going to start off by drawing my brownies just like before. And I have 6 of those brownies. Let's see. Okay, so I have my 6 brownies, and I have 5 friends. Okay, so that means that every single brownie I am going to break into 5 pieces. 1, 2, 3, 4, 5, and then I'll do that for all of the brownies. can just bring that straight down. 5 pieces, right? So now we can say the first brownie I'm going to share with my friends. So friend number 1 gets that first piece of that brownie, that second piece, right? For every single piece of brownie, my friend is getting a new piece, right? So if I were to add this up, if I look at my friend who is being represented by this red part right here, I want to add that up. I have 1/5. Okay, I can do 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, another fifth, plus 1/5. Okay, we learned how to add. Remember, we add the numerator straight across, right? And the denominator stays the same, right? Because we are still breaking it up into 5 pieces. So the denominator stays the same, but we add these numbers. 1, 2, 3, 4, 5, 6. 6/5. And we see how that's represented right there. Just like we had before, we broke up our brownie, and I knew that everyone was going to get a whole because there's enough whole pieces for everyone to get a whole, and then a little bit more. Okay, let's move on to another problem. This problem is on page 474, number 5. And it says 4 people equally share 9 brownies. How much of a brownie does each person get? So I have, first, I have to write my expression. What is my expression? Well, it says I have 4 people, so that's kind of important to me. And it says that I'm sharing 9 brownies, okay? So what am I breaking up into wholes? That's what I want to start with. That's what is going to be my first number, right? What am I breaking up into pieces? Well, I have 9 brownies, right? And that's what I can break up into wholes, so that's my 9. And I'm sharing it between how many people? I'm sharing it between 4 friends, so 9 divided by 4 is what our problem is. Well, here, this is great because I can use multiplication to help me, okay? I know that 4 times 2 equals 8, right? So that means that if I have 4 people and everyone gets 2 brownies, that's 8 brownies. Now, all I have to do is that leftover, right? I have 1 brownie left over, and I want to break that up into how many pieces? I have to break that into 4 pieces, right? So when I break that up into 4 pieces, each person is going to get 1/4 of the brownie. So each person gets 8 and 1/4. And now let's check this this piece right here, where I said that everyone gets 2 brownies, because that might be a little confusing for some of us. So I'm going to draw 8 brownies here. I didn't have enough space, so I drew it kind of to the side. But if we see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 brownies. Okay, do we see those 9 brownies? Now each person, I'm going to give 1 brownie, right? I have 4 people, so I get 4 colors. 1 for you, 1 for you, 1 for you, and 1 for you. Okay, everyone right here gets 1 brownie. That's 1 representation. If I'm that friend, I get 1 brownie, 1 brownie, 1 brownie, and 1 brownie. Okay, do I have brownies left over? I do. I have all my brownies that are on this end right here. So now I want to break up that one. That's another brownie for that friend, another brownie for that friend, another brownie, and another brownie. So now I go to that one, and that's the person in red, right? That's being represented by red, gets 2 brownies. This person gets another one, another one, another one. But wait, now there's this piece that's left over, right? I have 1 more brownie, and that one I have to break it up into smaller parts, right? So that person gets 1 brownie. That person gets 1 brownie. Not 1 brownie, 1/4 of a brownie. So now I see, what is my answer? Okay, right here I wrote the wrong answer. Oh no, so I'm correcting myself right here. I wrote 8 1/4. Everyone doesn't get 8 pieces. This was 8, right? If everyone gets 2 pieces, this is 8. So what should I change this 8 into? I have to change it into 2, right? 2 1/4. And I see that because if I'm the friend in red, I get 1 piece, 2 piece, and 1/4. So 2 1/4 would be my answer. Okay, here I want to show you a different way that someone might work that same problem. So we have 9 divided by 4 equals blank. Again, we have 9 brownies and we have 4 friends and we want to divide those equally. Some of you might want to draw out the whole brownies, all 9 of them, and I'm going to do that right here. Okay, so we have 9 brownies right here, and I want to divide them into 4. So I'm going to start by dividing the pieces into 4. I'm going to do that for all of them, and I know if I do it for one, I can just bring it down, and that will be equal. Each one has 4 pieces. Okay, and now you want to start filling in those colors, right? Okay, my friend in red is going to get 1 piece from every single brownie. And some people might actually like to do this. Like when we think about a cake, that's usually how we cut a cake. We have smaller pieces that we're cutting into, right? Or a pizza. Then we go on. We can put our second friend as getting that piece. Let's focus on our friend in the red though. And this person got 1/4 of this pizza, 1/4 of this pizza, 1/4. I'm going to write that for every single slice because they're all equal pieces. Okay, and I can add that. I can add 1/4 9 times, or I know that there was 4 brownies and there was 9 brownies, sorry, and I can do a multiplication, right? 1/4 times 9. Remember for this one, we make our 9 a fraction. 9 over 1 still is the same as 9. And then we multiply straight across. That's 9/4. Okay, so now our answer is 9/4. And do we see that? We have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, and 9/4. 9/4 is how much each person gets. Now I want to ask you, is 9/4 equal to 2 1/4? Well, if I were to think about this, I know that 4 pieces makes 1 brownie, right? If I do that, 1, 2, 3, 4. So that's one whole, right? I know that these pieces, 4 pieces, make another brownie. That's 2 wholes. And then I have my 1/4 left over. Again, this number right here is called an improper fraction. And it's an improper fraction because my numerator is bigger than my denominator. And then this one is called a whole number. Okay, this year we've been learning new ways to write division problems, right? In the past, we know that 3 divided by 8 is a division problem, and 3 divided by 8 is a division problem. And we've seen them like this, okay? But this year, we've been solving division problems, and we've seen division this way. 3/8. We know that 3/8 is a fraction, and it can also be used to represent division problems, just like these other notations right here. In the next few sessions, we're going to continue to think about fractions as division, and we're going to look at the decimal equivalents that a fraction might have. All right, guys, for this next part of our lesson, I need you to find a calculator. We're going to be using a calculator to help us find decimal equivalents for our fractions. So if you need to pause the video, this is a great time. Go grab a calculator. If you have an iPhone, an iPad, an iPod, whatever, all those have access to a calculator, so make sure you grab that. And I'll give you a little moment to pause. All right, so let's say that I want to find the decimal equivalents for these fractions, 1/2 and 1/4. And I don't know what they are. How can I use a calculator to find out? Okay, here's a hint. Think about the work that we did yesterday and what we talked about. Okay, so on that last screen, we had 3 divided by 8. And then 3 was in our house. And 8 was outside of our house, so how would I do that? Okay, so one way to think of a fraction is as division. The line is the division sign. So 1/2 represents 1 divided by 2, and 1/4 represents 1 divided by 4. If you do the division on the calculator, you will get the decimal equivalent of the display. So let's see how we can do that. So we can do 1 divided by 2, and that's going to give me 5/10. Okay, so the number on top is the first number we're writing, right? That's what's being divided, and the number on the bottom, the denominator, that's what we're dividing it by, right? So let's try this second one. The C is to clear it, okay? Some of us, we might not be too familiar with the calculator, right? But this one clears it right here. So let's do 1/4. We do 1 divided by 4. And can anyone guess what that's going to give us if we have one whole and we're dividing it by 4 pieces? I like to think about quarters when I think about fourths. That gives us 25, just like 25 cents. We have $1 and we divide it by 4. Well, that gives us 25 cents, right? So let's try a few more. Let's see. Let's do 7/9. I do 7 divided by 9, and that would give us 7/7. Okay, when we have a number like this, like continues, a lot of people write 0.77 and we put a line over the 7. That line says that 7 is going on continuously. So we just want to put that 0.77 with a dash over it. Okay, so I want to go back to that 1 divided by 2, and I'm going to write right here a few how it would look. It'd be 1 divided by 2, right? And we would write that as 1/2. Okay, what other ones would give us 1/2 or 1/2 equivalents? Well, we would also have like 2 divided by 4, right? Isn't that the same? How would we write that though as a fraction? That would be 2 over 4. Okay, is 1/2 and 2/4 equivalent? Yeah, that would be the same. And something I want us to notice, I'm going to do one more. 3 divided by what would give us that same half equivalent? 6, okay. If I were to plug these all into the calculator, all of these would give me the same answer. It would all be equal to 5/10. Oh, sorry, it's a little hard to draw on this one. Okay, 5/10, okay? And I've heard some people say this year that we can't divide a smaller number by a larger number. But that's exactly what we're doing. We're doing a smaller number and we're dividing it by a larger number, okay? What do you think about the statement when you divide 1 by 2 and 2 by 4 and 50 by 100, we always get 5/10. And why do you think this happens? Okay, and I kind of gave you the answer already, but these are all equivalent, right? These are all equivalent fractions. So that means if they're equivalent fractions, our equivalent in decimal is going to be the same. So now let's try, what two numbers can you divide on a calculator to give you a quotient? Remember, quotient means that it's the answer in division. So what two numbers can we divide by to give us a quotient of 2? I want you to try a few on your calculator. What divided by what equals 2? Give you a few seconds here. Okay, why don't we try 50 divided by 25? Can you do that on your calculator? So I'd write 50. I divide it right here by 25. And my answer is 2. We're going to continue to think about fractions as division problems. And we're going to also think about what the decimal equivalents are. And this is what you'll be doing on your homework, so make sure you're paying attention, okay? It says, look at the list of basketball teams and number of games won and lost. How do you think the decimals are computed? So here's a list of some middle school basketball teams and the numbers of games that they won and lost during one season. Look at this list with a partner, okay? Or by yourself, not with a partner, sorry. How do you think the decimal in the last column are computed? What do you think they mean? And look at the relationship to the numbers of wins and losses. Okay, so let's find some decimal equivalents on this problem. So I'm going to let you look at it for a little bit and try to figure that out. Okay, so right here, some things that I see, the people who have greater wins than losses, their decimal equivalence is bigger, right? Than the people who have less wins than the losses, then their number is smaller, right? Their decimal is smaller. So the way to find the decimal, you have the total number of games played, and we figure that by adding 29 and 11. Okay, so we have 29 and 11. Let's look at that one. The Dragons have won 29 games out of 40 that they played, right? So they have 29 out of 40. So if we add that 29 plus 11, let's do that right here. Because this is still games that they're playing, right? The 11, they're just games that they didn't win. But they played them. Okay, so how many games in total did they play together? They did 40. They did 40 games, right? So the Dragons have won 29 games and they lost 11 games. And to figure out how many they won, we need to do a decimal equivalent. So we're going to write 29 out of how many games did they win, right? And we're thinking about division. 29 out of 40, right? And we can write that as 29 divided by, right? Because our division is this part right here. That's our division symbol. 29 divided by 40. And that is going to give us that answer that we have, which is 0.725. And if you have a calculator, I don't have a calculator right here, but you can type that in, right? 29 and then divided by 40, and that would give you 725 thousandths. And that's what you're going to do for all these problems, right? You have to think about how many total did they win. We have to add, right, the wins and the losses. and then you do that over how many there is. So let's see, 26. Ooh, 26 plus 13. That gives me 39, right? And how many wins did they have? That'd be 26 over 39, okay? Do you see why we're adding? We're adding the wins and the losses because those are still games that they're playing, and I want to know the average of how many, what was the score that they got when they won. And let's look at this one, this Eagle one, 19 over 19, right? We know that if I win half of the games, 5/10 is equivalent to 1/2, right? I would still have to add 19 plus 19 and then have 19 over whatever 19 plus 19 is. Okay, and that's how you're going to figure it out on page 477 to try to figure out what the decimal equivalence is, and then you're going to rank who was the person that won the most games, right? Here we already know that it's the Dragons because we were given the decimal equivalence, right? They won most of their games during the season.